What we do here is that we're basically checking if this is valid or not. Fundamentally speaking, I think it's a sort of like a checker that checks whether my item is correct or not. So I check this one, it's also correct. So and you may ask like what is like a wrong format. So this is wrong, and obviously when you say that this is wrong, obviously the order do matter. So signing this one, number 2 is signing correct and 1 is wrong, and obviously from this you can tell that this order does matter. And the thing that when this thing actually comes to you, intuitively speaking, you think of the computational function of like stack, because order do matters, right? So based on what item is your last item, you have to close accordingly to what the item is. So therefore, for this item, you have a particular item that you need to close with, and you have to bring the item close enough first. So that belongs to stack. And when we talk about checking which item belongs to which, we then refer to hash map. It's like a very much popular way of um, checking if an item is like the correct one or not, right? So therefore, we talk about this fundamental checker thing, that we do use the mechanism of the hash map. So zooming in, we can actually see that they are actually implementing the hash map to actually try to solve the problem. So if we were to actually zoom in and see how they actually use the mechanism to actually work, is that intuitively speaking, The key value, because a hash map usually involves both a key and then a value. So similarly, usually the key will be the item that is the one that is uh, used to check the item at the very first place. So on top of the stack is usually the item that it's the closing one, which you see over here, is usually used as like the key. So in 2 you can see that the item is actually the closing item, and in 1 obviously that item will usually be the case for you to actually check because it's on top of the stack. On number 2 it just shows that what item is on the most top of the stack, which is the closing one. So therefore you got to accommodate to your 1, which is your key, have to be the one that's closing. So as you see in stage at Z, you do see that usually the key is the closing one, and for your value is usually the opposite end, which is on the flip side item. So you see that B is usually the opposite of A. So if A is a closing one, B will usually be the opening one. So you kind of like rinse and repeat, close and open, and then close and then open. And if we were to dive deep into the stack mechanism, I feel that once you go into maybe say a stack, because how a stack, you have these different layers, right? And we do know that the order do actually matter. So maybe say we draw for this one, it start off open and then close, open and then close, and then open and then close. So the moment we see this item, we straight away use the course. We first thing is that we go through the hash map to check for the key and the value. So if it meets the condition of like both the A and the B, it will pop off from the stack 2 times. So this 2 item is being removed, and now it checks for this one. It checks for this with the hash map, and if it meets the condition of like A and B, go through Z to remove A and B. If Z tells me that okay, this is valid, it will remove both the A and the B, which for this case it will remove the close and the open. But if it say this item is like invalid, it won't then actually pop, and then it will return to the system saying that okay, this is not true, this is false. That means the whole item is a wrong one. But if it's true, it will continue checking with Z that it will then continue to pop off both A and B if the item is so-called valid. So if you were to actually run through this system, you are actually discussing on the key concept of the item over here. So first thing first is that you will run your element through the hash map to check whether if it's valid or not. And once it's valid, it's utilizing the mechanism of a stack to actually pop off your value. So these are pop the two items from on top. And then it will go back to the next element to check for the hash map again. If it's valid, from the hash map, we'll check the value. If it's correct, it will double pop and go back to the element and kind of like rinse and repeat process. So when we were actually running through the one, you can see how it works for two, where I go through the hash map and then it pop from the stack 2 times and then rinse and repeat. I mean, overall, the whole mechanism is using a checking mechanism. So therefore, we mentioned a lot about using the hash map. Usually, hash map helps us to actually check, because based on the micro mechanism, it does use the key to value to match the value to be able to help us check. And one mechanism that we use to actually delete data efficiently is using a stack. And usually the order of like the items also do matter. That's why stack is very useful for this case. So the first thing first is that the reason why we use a stack, we first and foremost talk about like the condition of an item. Firstly is to have like the order actually do matter. And I guess the next thing is efficient, but this is such a side thing. The most important item was to do with the order thing, that based on what order we would need to delete accordingly. Look for this case is that you look at this 1 and the 2. Obviously the items are similar, but the order is different. So therefore stack will be able to actually help us implement this condition effectively. So with that, I think that's the point about talking about the checker for the valid prerequisites. Everything comes to an end.